Hi, my name is Roy. I'm the CEO of Shoppimon. In Shoppimon, we use AI, artificial intelligence, to help our merchants make sure that the websites are functioning correctly. And what I'm going to try and do in this presentation is, in just a few minutes, explain the basics of artificial intelligence. So hopefully you get a sense of how it's done. Just the basic principles. We're not going to dive too deep into it. Let's see how we do. So diving right in, first thing we'd like to do is, when we talk about AI, what do we mean? Like, what's AI? What's artificial intelligence? And that is actually the ability of a machine to think more like a human being. So look around it and make decisions and draw insight and understand information in a way that kind of reminds us of human beings. It's a very soft definition, but that's the way, that's what AI means. There are many ways to do that. The heuristics way, statistical way. We're going to talk about something that is in the mainstream of AI these days, and that's machine learning. Specifically, machine learning is the ability of software to look at data sets, and build a model to solve a specific problem, much as the way that we as humans do. So let's say we need to figure out a puzzle. We'll learn from it. We'll do the first puzzle. The second puzzle will be easier for us. In the very same manner, we want to teach machines to learn on their own, based on data that we feed them, how to solve a specific problem. And it sounds very complicated. There are three main methods of doing that. The first one of these methods is classification. And that's the ability of a machine to look at something and put it in a group, classify it. So in the example that we have in front of us, we're looking at a picture, and we'd want the machine, the software, to be able to tell us what's in that picture and identify it. So it knows to identify a zebra and two lions within the picture. It tags it. And now we have an understanding of what's in the picture, or we have tags in it, and we can put it into groups. In order to do that, the software needs to know what a zebra is and how to identify it, and what a lion is and how to identify an image of a lion. So that's classification. We classified this picture, we classified this image. The second very common way of using AI is by clustering. And clustering as well is about taking things and putting them in groups, but the big difference is we do not know in advance which groups or what groups we're going to have. So we can look at the data and say, you know what, split this data into 2 groups, or split this data into 5 groups, and the machine will have to do that on its own without really understanding the data, but based on parameters that it deduces, maybe the shades, the colors, the contrast, etc. In this example, we have a set of images, and the machine learning algorithm is able to divide them into 2 clusters without actually knowing that one is cats and one is cars. So it just looks at the data, divides it into 2, and says these images are all alike, these images are all alike, and this is very helpful for us sometimes feeding new data into other algorithms. So now we have a set of cars and a set of cats, and we can teach other software how to look at these images. That's the second methods of AI. And the third is correlation, or regression, as it is called in professional terms. That's the ability to correlate sets of data. So let's say we correlate the time of day, the geographic location, and the type of a car, in this example a purple car, to try and understand if it's more likely to see a purple car in LA at 9 a.m. or London at 4 p.m. And the algorithm will be able to determine what's more likely. And this is very interesting when we're trying to correlate BI, so business intelligence, and get metrics together and predict if something is going to fail in servers and many other things. We just look at series of data, 2, 3, or 1,000 brought in together, and the machine learning algorithms will be able to correlate that and draw a conclusion based on that and past data. Let's look at a real-life example of using machine learning. Specifically, we'll look at our ability to automatically tag product images. So we have a lot of products, maybe thousands of products and images. We want to tag them so it will be easier for our users, for our shoppers, to find them as they move through the store. And you may see this, you may know this from Amazon or from shopping online. You sometimes have product recommendations. That's part of the process that gets these recommendations to you. Not only, but part of it. So in order to do that, we'll use image recognition, we'll try to improve search, and we'll use the classification algorithm, the first algorithm, the first method that we talked about of putting images into groups that we know about in advance. The first thing we need to do is decide on the groups. So let's say that we'll take pants, shirts, and dresses. These will be the groups that these are the tags that we want to tag our products with. The second thing we need to do is get the data, the image data, to a form that a software can digest. So that's numbers. And one very simple way to do that is look at an image and look at each pixel within the image and give it a number based on the color, the position, the position in the image, and then you generate a set of numbers for each pixel in the image that describes the image in a numerical way. So that will be the transformation of data that we'll create in order to feed that to the algorithm. Step number 3 will be feeding these images as after they've been transformed into the algorithm so they can learn. And by feeding them to the algorithm starts identifying dresses. So it will take the first set of numbers and we'll say, okay, that's what a dress looked like. And then the second set of numbers and say, okay, so this is what a dress looks like as well. And it will start generating a set of filters or a set of decision trees or some other algorithms. There are many algorithms that can do that. But basically it will create a software that is able to identify what a dress looked like or a shirt. So the new algorithm will be able to identify an image, a dress image. The AI algorithm is actually writing software. So the AI algorithm is taking the data and it's writing software, a new software that is able to identify dresses or pants or shirts. So now we have the new software written by the algorithm software, writing software. Now we're ready with the new software to identify images that are new. So not the set of images that we just used. We already know that these are dresses or pants, otherwise we couldn't feed the algorithm with dresses or pants. But the images that we actually want to tag, so our products, we're now able to feed them through the algorithm, and using the information from before, it will identify these images. It will tag the dress as a dress, it will tag the pants as pants, and we will be left with tagged thousands of images that are tagged automatically that our users can actually look for using these tags. So looking for a dress, looking for pants, etc. So that's how it works. Is what we described, AI is about to take over the world? Well, not quite yet, but it is very present in our lives. So we see AI everywhere, product recommendations, self-driving cars, predictive analytics for professionals in IT or software development, and even implementations in the medical industry. These algorithms are very, very good at identifying things, putting them together, and helping people or machines make smart decisions for specific things, solve specific problems. The challenge with these algorithms is that they're not as flexible. So an algorithm that identifies a dress is not an algorithm that will identify a cat or a flower. It will be easier, it's possible for this algorithm after training it to identify dress, pants, or shirts, but then in order to identify flowers, it will be a whole new set of training and writing new algorithms. So the flexibility is not there. You cannot shift. An algorithm that identifies dresses will not be able to play chess or drive a car. These are completely different algorithms, and that flexibility is a huge issue, one of the huge issues in I guess AI taking over the world or behaving very much like human beings. The flexibility is not there, but it is all around us. It is changing our lives. And it is changing the way we do things. So definitely taking over the world, or very present in the world in that sense. That's it. I hope that was quick, informative, and clear, and that you know a little bit more about AI than you did before. Thank you.